So if you look at the picture on the right side, each tiny little colorful dot that we call pixel, right, is going to become one such rectangular box when we expand it. All right, of course, then you will, as you play with some conventional uh, um, software, image software such as GIMP or Photoshop or Photos and all the software, you will expand until to some extent the picture will become pixelated, right? It's sort of like very blockish, and that's because you cannot expand, you cannot divide a pixel, you cannot subdivide a pixel. So you always reference a pixel like that. So therefore, the pixel is technically occupying a space, all right, occupying this whole block space. It's not round, it's not oval, it's rectangular. What else to talk about here? We don't subdivide pixel, and each pixel is kind of like atomic, all right? So it contains an integer. So where's the integer? Each cell or each pixel contains an integer. Now this is a bit confusing. What do you mean by integer? How does integer turn into color, right? So that's the role of the hardware. The LED little interface circuitry is supposed to look at the integer that's being stored in the memory, the graphics memory, and say, oh, this is integer 000. So let me display nothing. Let me display nothing. But wait, I thought you just said integer, so why is it 0, 0, 0, right? That's because we can understand 0, 0, 0 as the intensity for red, green, and blue. And that makes sense, right? Because the primary color, the way our DNA goes, we can detect primary colors, red, green, and blue. And mixture of them gives us all the brilliant colors that we see in the rainbow. So it makes it very clear, unambiguous to say, I want that particular red, the rosy red. So how does one go into producing rosy red? Well, we might say something like 240 intensity of red and maybe 200 intensity of green and 250 intensity of blue, something like that. Whatever it is, we can specify individual display intensity, and that pixel, as tiny as it already is, contains 3 color subpixels. Now I'm not contradicting myself. I did say pixels are not divisible by us, but the manufacturer of the LED display can and did subdivide it into 3 primary color subpixels, and each subpixel can produce or generate at different intensity, and that's the role of the hardware. So we don't need to think too much about it, but it is good to understand that actually each pixel can be programmed. For us, we just program it. We don't care about how numbers become colors, right? In that actually affects real life, because if the screen is too bright, you will go, oh, right? But if the screen is too dark, you go, oh, what is it? In both ways, you go, oh, right, isn't it? So it does affect your reaction, and that's why it affects the real world. So how does an innocent integer affect the real world? That is the role of the hardware. For us users, Python programmers, what we do need to care about is what numbers to put in. All right, so the R, G, and B, representing the integer intensity of each primary color, goes from 0 to 255 inclusive. 0 being complete lack of that color. So if you want cyan color, cyan is a mixture of green and blue, right? We will set R to 0, green to maximum 255, blue to maximum 255. So we can do that mixing. Okay, so I did say that these are 3 numbers. How come there is single integer? Because the 3 smallish integers from 0 to 255, they are combined in this manner. All right, they're combined in this manner to give us a single integer. Now, one might be a bit confused why 256. 256 is actually let me see, 10,000, right? 256 is actually 10,000 if you speak hexadecimal. 0x represents hexadecimal. So if you speak hexadecimal, I do a little bit, but not as fast or as quick. But no one is expected to be a calculator, right? So if you speak hexadecimal, then 256 square is actually 10,000. Why? Because 256 itself is 100, a very nice number, all right, in hexadecimal. So what does it mean? Well, because in hexadecimal, if we speak about decimal, then it's quite clear that r times 100 square plus g times 100 plus b basically means the first two digits are for storing blue, second two digits for storing green, third well, sorry, second pair of two digits, third pair of two digits are for storing red. That is, if the intensities go from 0 to 100 or 0 to 99, then this would work. That way, that we use 100 square and 100 here. But yeah, that's the way it goes, right? So each byte is 8-bit, and so 8 bits converted back to decimal places, we get 0 to 255. So just have a browse through this. You don't have to memorize this or think about even this formula. But what I want to discuss is basically why, when we are so conversant, so convenient for us to talk about color in RGB3 integers, why is it that each pixel stores only one integer? Okay, so I'm just giving you this uncovered magical formula. Nothing magical about it, right? And on some hardware, it's actually stored the other way around. It's BGR, right? So it depends on whether you're using Mac or Intel chips or Windows, Intel chips, and stuff like that. So all of these hardware connections to hardware, interfacing with hardware, very very detailed, a bit mathematical, a bit complex in a way that bogs us down when we want to achieve higher level business goal or computational goals. So suffice it to understand that, yep, there's a way to combine three smallish integers into a larger integer representation. All right. So each cell is just storing an integer, and the hardware will just dissect it on the fly in real time at a very quick speed to display the pixel integers on a 30 frames per second or even 60 frames per second basis for some of your mobile phones. Okay, so that's how it goes. So with that understanding, and I totally don't expect you to memorize this or to be able to explain all these, because I've gone through very quickly, and I've really not discussed the whole massive details involving displaying the pixels, and we don't have to. All right, well, because our goal here is to understand the concept, how Python sees an image. And we have a lot more higher level actions to learn. So this is just for background. And if you find this already seeing this expression, you are like, that's not for me. Skip over it. Okay, so this is next time when you operate on images more and more, and it comes to a point where you say, how did this go? I've been doing this and I didn't really quite understand. And that's possible, right? Imagine you are cycling, right? We can ride a bicycle a lot. We can get from point A to point B. We can speed it, but we actually don't know how the gear ratio go, and how does it shift gear, or what principle does it move that we can balance. And when we stay stationary, we fall down. We don't know all this physics, and yet we can ride a bicycle to get from point to point. So that's very common experience. So try not to get too bogged down by this. I want to talk about this because I find a lot of beginning students learning Python programming, when they come to images, it's just a bit hard, right? So I'm just attempting to show that, yeah, you can pick this up, but not necessarily right now. So next time if you find that you want to dig down even more, come back to this video again. All right. Okay, so I briefly talk about how the pixel colors can be programmed in Python, either as a tuple, yes, the Python's familiar tuple. So we can specify a pixel as a tuple of three smallish integers. And in future, I would just ignore the word smallish, because we all know that RGB, it's always ranging from 0 to 255 inclusive, right? Now, you can specify a pixel content as a tuple of three integers, or a code like this if you speak hexadecimal, right? So FF is kind of, after working through a little bit, represents 255. So 255 red, 0 green, 0 blue, that must be referring to red. Right? So for some of the familiar colors, you can just directly spell it out. I want red, R-E-D, and Python has, or rather the image library has internal dictionary to say, oh, actually I understand red as FF00. So you can get by with this. But of course, this is not all colors. If you want like a slightly gloomy red, maroon or whatnot, then maybe maroon is not defined, then you will have to spell out the hexadecimal value. Maybe it's hex, let's say A00000, right? So A0 means 160 in decimal, and that would be a tuple of bracket 160, comma 0, comma 0. So, point of advice here, never refer to any coordinate of a pixel using the words row or column and or column. So never talk about this 6,2 pixel as, oh, I want the row label 2 and column label 6. Because when you do this, you are subconsciously sabotaging your own understanding. Because when it comes to actual programming, all the image libraries, whether it is from Pillow that we are going to talk about, or maybe from future libraries that you are going to write or someone else is going to write, will always follow the X comma Y convention, because that's the community's convention and scientific convention. So you don't try to change that, and it helps if you keep speaking about X comma Y whenever we talk about images. All right, so that will automatically correct your own understanding. All right, moving on.